Okay, so for those of you that took a look, what you can't do is talk. I will kick you out. You can go ask Davis.
Davis Wall.
All right.
So
For each of the
crap.
following, identify the type of sample and tell if the sample is biased. Explain your reasoning. Number 1, a newspaper is conducting a survey to find out people's favorite sports. The newspaper asked every other person at a ball game, what is the type of sampling method? Systematic. We had a rule. We picked every other person. All right. Is it biased?
Yes.
Yes.
They're at a
Why is it
baseball-
biased?
They're at a baseball game. The best
Okay.
sport on the planet.
Only survey one sport. Or at a sporting venue. Okay, so we definitely get biased information. Probably most of the people at a baseball game are baseball fans. Alright. Number 2, a pet store wants to find out people's favorite animals. The store places cards at a table for customers to fill out as they enter the store. Sampling method, voluntary response. What's another name for that? Selected. Okay. Do you see much bias? No, I don't see much bias either. And there's either none or little bias. We had a little discussion about it earlier today that there could be a little bias because you're only surveying the people that enter the pet store, but that's where the pets are. So I didn't see much bias for that. Okay, number 3, a health club wants to know how often members attend aerobics classes. The club asks members who have just finished taking an aerobics class. Sampling method. Was that
Cluster.
word? Cluster. Cluster. All right. Biased?
Yes.
Yeah, it's biased because many people who join the gym and pay the membership and attend no aerobics classes. Some just go to lift weights. Some just buy the membership, stay at home, sit on the couch, and eat potato chips. So, when we survey this way, we are eliminating, or we have underrepresentation of different populations. Okay? Number 4. Comment on each of the following as a potential survey question. So this is our question. It has 2 parts. Is the question clear? Which of the following best represents your opinion on gun control? Number 1, the government should confiscate our guns. Number 2, we have the right to keep and bear arms. Is it clear?
Yes.
Yes, it's pretty clear. Which one best represents my opinion? Okay, and then the second part, is it slanted? I would say yes. And the one word that makes it slanted to me is this right here. Our. That makes it sound like they're going to come into my house, open up my gun safe, and take my guns.
Obama.
Hey, just keep your mouth shut. That never happened.
Sorry. It won't happen again.
It makes you sound unintelligent when you do that. And I really think
I
that's
get that
not
a lot.
true. Alright. Any questions about this one? Alright, there's more. We'll take a look at those another day. Okay, checking homework.
Yeah.
Are y'all really appreciating these 2-minute homework assignments you keep getting?
Yes.
Yeah. Today takes a little longer, but you should have some class time, so it'll balance out. All right. So we have some absences. And oh, that's our testing. I'll check for testing in a second.
This will be, I got into Clayton State.
Fabulous. You're going to do dual enrollment?
I am.
sure you take it serious. Is Sam AP testing or just out?
He's out.
Just out.
Okay, can you go for,
I think we are.
Sure. All right, so number 14 was about going to the dance clubs, right? Writer for Travel Magazine wants to learn tourist opinions about nightlife in the city. She decides to visit different tourist attractions every day for a week. She will have the magazine interns who travel with her interview every tourist they see at the attraction. So they're going to a specific location, interviewing everyone right there. Cluster. Now, she did it over several days, so it's several cluster samples.
I thought would it be partially convenient since it's whoever they're around?
It would be convenient if she didn't go anywhere. So if she was already someplace and said, hey, I'm already here. Who's around me? Any other questions? Okay, you didn't have to do 17, but I already had these for another class, so Alright. Woo! Hold on. Forgot to erase. Okay, so hopefully you picked up the notes as you walked in. If you didn't, take a quick moment and go grab them.
It's probably that we're choosing. Have you seen the video of those? Have you seen the videos whatever that happens? It's fake.
Yeah, I saw it.
Okay. So we have talked about distributions. We have talked about the shape of distributions. Today we're going to look at one we've actually already discussed. Remember when we looked at symmetric distributions and we said they were bell curved. And another name for that type of distribution could be a normal distribution. So here we go. Here's a continuous probability that is represented with a normal distribution. So, okay, characteristics of a normal distribution. The mean, median, and mode are all equal. And the mean is located here at the axis of symmetry. Okay, now remember we had two symbols that meant mean. X bar is mean of the sample, right? And then what did mu represent? Mean of the population. Okay, so we're referring to the entire population here. All right, the mean, median, and mode are equal. It is bell-shaped and symmetric about the mean. So this side looks identical to that side. The total area under the curve is 1. And what we're going to notice is that area under the curve is actually going to relate to the probability. The area under the curve corresponds to the probability. It approaches but never touches the x-axis as it extends further away from the mean. So if we look here, it's not exactly touching. And number 5, the points at which the curve changes from curving upward to curving downward are called inflection points. We've already talked about that. We talked about when it changes from concave up to concave down. That point where it changes is an inflection point. Well, here, with our continuous probability distribution, where those inflection points occur is exactly 1 standard deviation in either direction from the mean. So if you look at a graph and you can see those points where it goes from curving up to curving down, that point, that inflection point is 1 standard deviation from the mean. Now, what we're going to look at today is called the empirical rule. And the empirical rule gives us a really good estimation for the probability that that a data point lies within certain parameters. So, in a normal distribution with a mean of mu and a standard deviation of sigma, you can approximate the area under the curve as follows. So when we're looking at this picture, it says 68% of the area lies between plus or minus 1 standard deviation of the mean. Okay, so 68% of that data lies within 1 standard deviation of the mean. So from here to here, 68%. 68% of the data lies within 1 standard deviation of the mean. Okay, that's what this says. The 95% lies within 2. So if we came out to this direction and went over to that direction, 95% of the data lies between here and here. Okay, so from here to here, 95. That first standard deviation, 68, from here to here. And finally, 99.7% lies within 3 standard deviations of the mean. So from here to here. And that 3 standard deviations of the mean, you may be thinking, we've already talked about that. Well, we did, but we didn't apply it. That is points that lie outside of that are considered outliers. So when we have our data that lies outside of 3 standard deviations of the mean, that's another way to determine outliers. So in this case, outside 3 standard deviations of the mean would be outside of this 99.7%. So we know that only 0.3% of the data is going to be at either tail. Okay? All right, how do we use it? All right, so the first thing I'm going to do is talk you through an example that's already done. The second thing I'm going to do is an example with you that is not on your worksheet. This is like a you watch, and it hopefully makes more sense. Okay, so the first one shows you what we'll be doing every time. With the empirical rule, let's put our phones away. We're going to draw the curve. We're going to label the mean. So in this case, it says mu is 20. The mean is 20. We start with 20. And then we'll label each standard deviation because the standard deviation is 4. So if we went plus 1 standard deviation this way, we'd add 4. And then we go 2, we'd add 4 more. Then we go 3, we'd add 4 more. And we label this. And now we go the other way. So we go back 4. We go back 4. We go back. And we label each of these points. Then we can answer questions about them. So it says, what is the probability that x is between 16 and 24? Well, between 16 and 24, that's just 1 standard deviation on either side of the mean. That is your 68. So what is that probability? 0.68. Now, what if they had asked us something different? Let's talk about where these numbers come from. Actually, let's start with these. If this is 0.68, and we know it's symmetric, this half and this half would have to be the same. So you take the 0.68 and divide by 2. Okay? Now, let's see if we can figure out how we determine this value and this value. So, if we take this 95, which goes from here to here, and we get rid of this part in the middle. So if we did that 0.95, and we get rid of the middle, then we have these 2 equal areas. So we divide that by 2, and it gives us the area of this light gray part and the area of that light gray part. So that is the area under the curve, and that area is going to correspond to the probability. So this is 0.27, and when we divide 0.27 by 2, we get 0.135. 0.135. That's where the 0.135 comes from. Now this one here, same concept. We take that 0.997 and we subtract away the 0.95 and divide by 2. So that gives us 0.047 divided by 2 And 0.047 divided by 2 is this and this. Now, when we add up all of these, it doesn't add up to 1. And what did I say the area under the curve was? 1. So we're missing something. We're missing this little tail and that little tail. Those tails are what's left between 99.7% and 100%. So what you do to find the tails is you do 1 minus the 0.997 divided by 2. So it's 0.003 divided by 2, which is 0.0015. 0.0015. Very little lied out here. Okay, so we're going to create our own distribution here. We're going to label the mean and the standard deviations, and then I have some questions to ask you. Okay, so if this mean right here, mean represents the average number of points that Drew scores in a Star Small High School basketball game. Okay, and this is the standard deviation. So what we would do is we would come right here and label our mean 15. Because that is the mean. The mean is 15. Okay, so you're just watching this happen. The standard deviation is 3. So this would be what? 18. This would be 21. This would be 24. This would be 12 and 9 and 6. So, we know that these areas under the curve don't change. That's what the empirical rule tells us. So if from here to here is 0.68, then this is 0.34, this is 0.34. These are not going to change either. So this is also still 0.135. This is still 0.135. This area and this area do not change. That is 0.0235. This is 0.0015. So the area under the curve does not change when we're looking at a normal curve. Now, how is that helpful? What if I ask you what the probability of Drew shooting between 12 or scoring between 12 and 18 points would be? Well, what is the area under the curve between 12 and 18? 0.68. Okay, what if I ask you what is the probability that Drew scores more than 18 points? What would we have to do? Look at what's above 18. This plus this plus this. Okay, so we say 0.135 plus 0.0. Maybe quit working. All right, 0.235 plus 0.0015. Add them up. See what you get. Now the interesting thing is, because this is greater than 18 and this is symmetric, then less than 12 is going to be the same, isn't it? Greater than 18, less than 12, they're the same because it's symmetric. Okay, what if I ask you, what is it greater than 12? we could do 1 minus less than 12. Remember probability? These are complements. So less than 12, greater than 12 would just be 1 minus that probability. The other thing you could do is, from here over is 50%, isn't it? So from here over is 0.5, and then if I added 0.34 to it, what is 0.5 plus 0.34? 0.85. And that's how you would use your probability distribution. Does that make sense? Okay, you try this one then. Uh-oh. You try the one at the bottom of the page that says you try. Okay, you're going to have to sketch your own curve. You're going to have to label your mean and your standard deviations.
You can't read what the mean is.
The 100 guys.
You can't read it?
No, my whole bunch is on it.
I saw
Oh, okay.
Thank you. And there's the
There you go.
I hope not.
I distracted myself. He doesn't know.
That's 150
You know what I do every day? At least 4 hours.
Good. Here we go. Very far right here.
How many numbers do we have to get? 3?
Yeah, 3 standard deviations on either side. That's what you do every time.
Yeah, I kind of. Alright. Yeah, okay. So, whatever your mean is, you go in the middle, and whatever the SD is, you go up 15 on this side and down 15 on this side. That's pretty much it. Okay. I think then
Oh yeah. This movie is almost hunting season.
Almost hunting season? What kind of hunting do you do?
Little kids. Spring
What?
football. Little kids.
Alright, you probably should have said that.
That's why I followed up with little kids. But I left a note in there for confusion on purpose.
And we learned that both of these, this is like the same.
Miss Wilby was confused.
Okay.
You know now
So,
that
like,
there's like an
this is
overpopulation
this.
of deer,
It's like
like
this.
it's legal to
No matter
shoot
what.
one like in your front yard.
So like this is point
I don't know if that's true, but-
Without, like, you can't use like a high powered rifle. You have to use like a
0.35. Like I'm literally just comparing. They don't change. Okay. And then
You know,
um
if you aim for the brain.
She shot it like 100 pounds.
You guys remember that old drama
it says
teacher?
from
The bald one?
85
Swallow the
You remember the old
Say
drama
85 to
teacher?
145,
Remember shooting
and I think we
squirrels?
just add up the numbers all the way
I-
from 85
Yeah,
to
I was
145.
a squirrel.
Alright,
I
we
brought
have
the
lots of extra
destruction.
talking going on, so I think we must be done.
I think.
Oh,
So let me bring all this back and we'll talk about it.
In here, I don't know.
Okay, so the first thing we do is label. 100, 115, 130, 145. Go backwards. 85, 70, 55. Alright, now I chose to do it this way where you add the 68 and that. We also, there's other ways you could do it. You could have done 34 plus 34 plus 34. But you should have gotten 0.8385.
How do you find how many standard deviations there are?
Okay, so First thing you do is you create your probability distribution. So if you go back 1 from 100 to get to 85, that's only 1 standard deviation from the mean. But this one, to get to 145, I go to the right, 1, 2, 3. So that one's 3 standard deviations to the right of the mean.
That makes sense. So 85 is only
1 standard deviation to the left of the mean.
minus 1, and that one's plus 3.
Correct.
Does that make sense, Cole?
Sweet Caroline.
I'm recording, Hayes.
Like, I honestly did not know. But I can keep singing if you want.
Okay.
No, no,
So
thank you.
define this.
I watched the YouTube
This is
video.
the starting point. How many places?
Okay.
Like,
Now, the back of your sheet is just trying
but you're really
to
going
get you to put the pieces together.
this way.
Now, we know that when our curve is spread out, it has a greater standard deviation versus when it's a compact curve, it has a smaller standard deviation. And now we can estimate those. Like the mean is going to be the middle, so the mean of this one is about 3.5, and the standard deviation is the distance from that mean to that inflection point. So this one appears to have a standard deviation of about 1.5. Now, this one has the same mean. The mean is still 3.5, so it's not shifted any on the axis, but it has a different standard deviation. We can tell because it looks different. Okay, so this one looks like it's about over 1. The standard deviation appears to be about 1. Now these look identical, and they do because the standard deviation is the same. But this one was shifted, so the mean
1.5.
is different. Very good. Okay, so B. Which normal curve has a greater mean? So when we're thinking about mean, which one shifted further to the right? A. Which one has a greater standard deviation? Which one stretched out further? B. Okay, so you try C. You try part C at the bottom of the back. Some of you missed the flipping of the page.
Yeah, I got it.
Country road.
On the line to the
West Virginia.
What's an inflection point?
What did Davis do?
Is the
Another
inflection point
class?
just the points on the right? This one or on the other point?
The inflection is where it goes from curving up to curving down.
Okay.
About right there.
Thank you.
Wait, like right here?
Nope, that's the max.
Wait, which one are we doing?
Over here?
C.
These? So this would be 3.5. Correct.
Wait, I don't know what the inflection point is.
The inflection is where the curve switches from curving up to curving
Guess what spell
down.
EPI
From
is?
concave up to concave down.
Oh, okay. No, literally,
Me too.
right here it's concave, but then like right here it's like that. See that? It's like the in-between. Pretty much in between this. Up there. It's pretty much the middle of them. You don't have to say what they are.
You have to go through it.
Standard deviation is how. Standard deviation is how much it's moving. So this one's obviously going by 0.2, right? 0.2. It's going from 0.5 to 0.7 to 0.9.
Oh, yeah.
But and then the M is
No, we'll change it.
Okay.
and then that curly hue thing is how
Alright,
much
so
it's going up.
the mean is about 3.5. That's where the axis of symmetry lies. The inflection points are approximately
Who's source?
0.2 of a
This is how
foot.
EPI is.
in either direction, so the standard deviation is 2/10.
I think that's.
Any questions?
That's what you're gonna do.
Alright, while you guys were working on that, I passed out your classwork. What you don't finish in class becomes homework. Let's get going.